The integrating factor method for solving first-order differential equations is an extremely useful tool. However, where does it actually come from? Well, if we consider doing the product rule on the function r of x multiplied by y, what we will get is something extremely similar to our first-order differential equation seen before. This equation is quite easy to solve since we can just reverse the step we did before and then integrate using the fundamental theorem of calculus. This will then just give us r of x, y. So if we can visually turn our original equation into something similar, we can apply the same visual method. Multiplying by r of x will give us r of x dy by dx. However, our r of x p of x is not quite the same as r primed of x yet. So to fix this, we'll need to equate them so that we can visually get our r of x p of x to look the same as r primed of x. Doing this yields us a differential equation in this form. However, if we divide by r of x, we get something that is quite easily integrable on the left, since we can just use the standard result for the natural log to integrate this. Now that we have r of x in terms of p of x, we can get rid of this c plus c by the fact that the integrating factor is just more of a visual trick rather than an actual value. It doesn't actually change our differential equation, only scales it by a certain factor, and so we can just get rid of it. And then exponentiating, we get the integrating factor.